Hello, everyone, and welcome to our live YouTube event. I'm Greg Whalen with Arizona CNC Equipment, and I'm here with my friend Jason Martis from Allied Machine and Engineering. Allied, as many of you know, are a well-known manufacturer of cutting tools, and what we're here to demonstrate today is how some of their finest products can be put to use in manufacturing components for the firearms industry. Jason, you want to tell us a little bit about what we're going to see today?
Yeah, for sure. Unfortunately, we won't be making the gun of Rambo, but I think we have something better here for you that I think we all can appreciate. We're going to be doing the upper and lower for an AR-15. So with that, I'll go ahead and show you some of the tools. Start things off with a Vortex. Okay, this is going to have a peripheral insert, and then for the center insert, okay, you have a cutting edge and a cutting edge here. You're going to take this insert out once it reaches life and bring it over here and rotate it, and that's going to give you 4 cutting edges, okay, per insert. All right. Once we do that one, we're going to be doing a thread mill. Now, with this one, we're going to show is a solid carbide version of that. So with that, Greg, you want to tell us about the M460?
Well, yes, the machines that we've chosen to showcase these cutting tools are from Okuma. The ones that we've selected for today are Okuma's Genos line of machines. The first of which is the Genos M460V-5AX. Now that machine is a fully integrated 5-axis simultaneous machining center with a vertical spindle. This machine and spindle is 15,000 RPM, 30 horsepower, 150 foot-pounds of torque, with a dual range winding in the motor, which allows us to achieve that high torque down as low as 50 RPM. But for high-speed cutting, 15,000 RPM, we've got a Big Plus Cat 40 spindle, which allows us tremendous rigidity. And with the rapid speeds and feed rates of over 1,200 inches a minute, this machine is capable of doing heavy cutting in 5-axis as well as fine finishing work.
Okay, so here we're going in, and this is going to be some milling work that's done. This is not Allied tooling, but we will have that coming up here directly. This is some footage that we took to show the process that it takes to finish one of these and get it down to closer to a finished product.
Yes, here we can see the fully integrated 5-axis cutting on this machine. And the beauty of this machine, too, is it is a very affordable, full-function 5-axis. Capable of the tightest tolerances, the machine has scale feedback on the axis, and it even comes with a 5-axis auto-tune feature, which means that any time during its life cycle, you can recalibrate that machine and make sure that it's still maintaining the accuracy that it had when it was new.
Okay, so what we're going to show you now is what we start with is with a raw block of aluminum, and we're going to go ahead and start that down and start off with the Vortex, and we're going to do the mag weld. This is going to be a rough cut just to remove as much material as we can, make much smaller chips to make it manageable to come in and finish it up with the milling tools and also offline operations. So the first hole we're going to see is going to be a Vortex for the mag weld. Okay, here we go. Now again, this is just a roughing. We're drilling from solid here. And one thing to note is this machine is not equipped with through tool coolant, so there is a flood. That's why you see the pack going on. Now, if we had through tool coolant, we would be able to drill it straight down through. So now we're coming over and we're going to be drilling roughing holes out for the trigger guard. One solid hole, one solid hole. And then the next 2 holes are just going to be pretty much just to remove material because it's coming milled out to be separated later on, just to get material out of the way. And now pay attention to this cut. Now this one here is going to be an interrupted cut, so we cut our feed rate in half. Prior to this, we were running at 2 thou. Here it's only a thou. We've maintained the same surface footage in RPM. And again, this is a roughing hole for the thread mill. So again, if we revisit the Vortex drill, see the peripheral and the center, we have different geometries depending upon the material you're going to be drilling. We have it specifically for aluminums, steels, cast irons. contact application engineering. We'll be able to assist you in choosing the correct geometry. Those come in packs of 10 and readily on the shelf. For the thread mill, we have an example. Here is a T3 solid carbide. This has T3 cutting teeth. Okay. What this provides is, if you had a full-length carbide down here for a full thread, that deflection is going to vary from top to bottom. So with this making a single pass, that deflection is the same from top to bottom. Okay. What we're going to see here in the demonstration next is not a T3 or an indexable. It's going to be a solid carbide. So it is going to, pretty much just do everything in one shot, one single pass. Now here we're running an 1 3/16 UN thread, 685 surface foot at 1.0017 inch per tooth. Okay. That was a 4-fluted tool. As you see, it didn't take very long for that to be completed. So with that, we'll go ahead and switch it back to you, Greg, and you can tell us about the M560.
Oh, with pleasure. This is one of my favorite machines in the Okuma line. This is the Genos M560 vertical machining center. And one of the things that people notice right away about this machine compared to a typical VMC in the 20x40 range, the construction is very different. Most machines in this category you see are table saddle machines, where the table is supported by an X-axis set of ways as well as a Y-axis set of ways. So the table moves in two directions. What Okuma has done is they've incorporated their double column design on this machine. What that basically means is they separate the Y-axis from the X-axis, and the X-axis is on this cross rail above. So we've got over 40 inches of travel in X via the spindle above the table. The table itself is fully supported by the Y-axis ways. What that does is several things. Number one, separating those axes gives us more accuracy in the machine. It also provides more stability. And on this particular machine, we've got the ability to handle a 2,000-pound load on that table. The unique thing about this too is with this way construction and the fully supported table, you can have that load where it doesn't have to be centered on the table. It can handle an off-center load and still maintain the same speed, accuracy, and cutting capability as a centered load. What you'll notice what we have on this table is we have a sub-table or fixture plate, several fixtures mounted on top of it, and we also have on the right-hand side a relatively heavy rotary indexing mechanism. So again, it's an off-center load, but that doesn't have to scare us because this doesn't affect our accuracy or our performance in any way. A couple of the other unique things about this machine is the spindle itself. This is a 15,000 RPM, 30 horsepower spindle, which uses a dual winding for the motor, which means we have full power down, torque down to 50 RPM via the dual winding changeover from high to low RPM. Also, we have a 15,000 RPM maximum spindle speed, which enables us to take advantage of the rapid feed rates of the machine for doing fine finishing at the high RPM range. Now, one of the things you worry about with high RPM is the heat of the spindle. Well, in this case, that's covered because Okuma has this spindle jacketed with a thermal jacket of cooling fluid. That's a separated cooling fluid, doesn't work on any other part of the machine. And what that does is it maintains the temperature of that spindle to within plus or minus 2 degrees, not to a random 72 degrees, but a plus or minus 2 degrees based on the temperature of the rest of the machine and its environment. Well, how do they do that? Well, because they have thermal sensors placed throughout the castings on the machine, which monitor the temperature of all the components. And the spindle needs to be maintained to plus or minus 2 degrees of the temperature of the rest of the machine, not just an arbitrary figure of 72 degrees in whatever environment you might be in. By doing that, we maintain our accuracy. We also maintain the life of the spindle. Okuma does build their own spindles, and oh, by the way, they build their spindles with a rating of 20,000 RPM, 20,000 cutting hours on the spindle, which is about double what our typical competitor would rate their spindle at. A couple of the other things with regards to thermal forces on the machine. As machines get more modern, they get faster. The faster a machine moves, the more heat it generates. What the problem there is that the heat causes metal to expand. Therefore, your machine is not holding the same dimensional tolerance it did when it was cool. What Okuma has done is they've taken great strides to maintain anything that's a heat generating component is not a part of this machine. It's on the outside of the machine. Where you get most of the heat is in the cutting zone when the hot chips go up against the machine casting. Well, again, what Okuma has done is they've insulated the entire machine envelope with sheet metal, so nothing in the machine envelope is ever going to touch the cast iron structure of the machine. And therefore, once again, we maintain thermal stability. This machine has a 1.2 second tool change time with the ATC. This one has a 32 tool magazine capacity. And to get those hot chips out of the machine environment, we also incorporate 2 standard coil augers, which take the hot chips out to the rear of the machine where they no longer influence the heat zone or the growth of the machine casting. This is one of my favorite machines, and these features and many more are really what make it the leader in its class. 20 by 40 machining centers, this Okuma GENOS M560 is #1. We want to do some cutting?
Yes, I do. Yes, I do. I'm excited for this. Make some chips.
All right. That's
Okay.
what we're here for.
All righty. So yeah, not only did we bring Vortex and with threading, we also brought Superion tools here to show and display for the first time for you to see some capabilities of this. Start this off by saying what you see here is not a manufacturing setup for that you would do it for a normal process. Daniel has done a great job of making these fixtures and setting it up to display the capabilities of our tooling, as well to display the operations that goes through the process of making one of these all on one bed. Okay. Some things we need to reiterate here is that these parts represent visually pretty much only. The tools are capable of making 2 spec. Unfortunately, Greg, I'm sorry, these aren't exactly 2 spec and won't be functional.
So I can't use these parts when we're done today?
No, not today. No, I'm sorry. These are probably going to be scrapped and destroyed. So I'm sorry. But anyway, we're going to start things off, make some chips here. We're going to use the Genesis to go down through. Reiterate here that this is a flood coolant application. Okay, this machine does not have through tool coolant, which the tools are designed for. That's what we want. That's what we prefer. So with that, just bear with us. We have to do some practices here to make sure we're making a decent, acceptable chip and we're getting it out so that we're not packing it up and breaking any tools. Don't want to break any tools today. So Daniel, if you will, please. Sure. Okay, so the XT Pro here, we're going to be coming in. We've already pre-drilled the one for the other side for the next operation. We'll get that here in a second, but parameters here is going to be a 984 diameter. We're going to be going 4.4 inches deep, 555 surface foot at 17th hour rev. That's going to figure out to be about 36 inches a minute. Quickly for metric is 170 on meters a minute and 0.43 millimeters of rev, 930 millimeters a minute. With that, and you saw that with the PEC cycle, we were making chips, we were getting them out, and with that full retract, you have no issues of packing off and creating an issue. So some features of the Genesis tooling. You have your high penetration replaceable tip. Get this in focus. There we go. That there on the OD is going to be your coolant outlet to feed pretty much the OD, the margin of the insert. It's not going to come in too good here if we get the lighting. You can see there's also a coolant spraying toward the center of the notch. What that's going to do is, as this tool touches down into the solid material, that's going to provide a little bit of coolant and keep that cutting edge, maintained and everything as it starts the deformation of the material right at the notch area. Curved cutting edge as we come out to the OD. Get that to focus in a little bit better. There we go. So you can see we have a curved cutting edge coming out. That's going to give some radial force to break that chip off and create a nice tail force. So we have a nice small chip that gets evacuated out. Okay. So next we're going to be running a reamer. So Daniel, if you will, please. Now, one thing here that we want to touch on and note is with the reamer, the way we're doing it, we didn't go full depth with the Genesis tool because of the flood coolant condition, okay? So what we did was we flipped apart and now we drilled a hole and we're going to connect those two now with the reamer. With the reamer here, it's going to be a 1-inch diameter going 8.7 inches deep. As you noted, much deeper than the 4.4 inches before. 445 surface foot at 18 thou rev. That's going to be about 30 inches a minute. And what we're looking for here is a nice finish to minimize any excess of work we have to do for deburring. We want that nice preserved surface finish when we're done with it. Okay, so what you just saw run there, this is a replaceable head reamer. This one is a 1-inch diameter, okay? And it's going to set up in the arbor. The arbor here, we stock these. There we go. There we go. We stock these. These are ready to go off of the shelf. The heads are available in 15 days. And the reason we do that, these are made to order. So what you're going to want to do is contact us. Let us know the tolerance you're looking for. We can set these up. We have different lead-ins, different coatings, substrates to match the application that you're doing. Here we're doing, primarily the 6061 aluminum, but we have these all set up for steels, cast irons. Do this quick assembly. Here we go. That slides in. And then we have, this here is going to be set up. I'm not going to screw it all the way down, but that'll go down flush, and then that will set up for your, this is through hole, we don't have to worry about anything, but this nut we also offer for flat bottom applications. Okay, so with that, we're going to go back into our part here, and we're going to be revisiting the thread mill operation. What you saw in the first demo was a solid carbide version. This one here, what you're going to see coming up next is indexable, and again, we have the T3. Okay, so with that, we'll go ahead and come back to Daniel, and he's going to show us the thread mill operation. This here is going to be coming in for the castle nut. And there we go. This is going to be rather quick, a single pass. And there we go. We had a little bit of chatter. This is doing an OD. It is thickening up a little bit high in the fixturing. That could, create a little bit of harmonics, but, other than that, it didn't sound too bad. That was pretty decent. So with that comes the fun part. Start this off for the Picatinny rail. Will be our next operation. And if we can come down here, you will see the tools we'll be performing with that. These are PCD. Okay, this is a solid carbide base material, and we utilize a PCD wafer that's brazed in, and that'll be finishing the complete form of the OD work for the dovetail of the Picatinny rail. Okay, so with that, we'll go ahead and change this back to Daniel. Daniel, if you will, please. There we go. We're going to exercise the 15,000 RPM of this capability. That is correct. Okay, we got to change up a little bit of parameter here. We had a setting we have to do for that transition to be able to crank this up here. So we'll be right back with the live demo. While he does that, if you can switch me back down below here, show you some examples of some other. This is for drilling from solid. This would be back to our normal operations of hole making. Okay, again, we have the PCD up front. That's going to be, and for this particular tool, that would be to do a solid diameter and finish up. That's the most critical. The steps back here at the back, that may be doing like a chamfer, something that's not critical, just to do an edge break. Okay. To get away from the PCD and bring it back a little bit, here's an example of a reamer that is multi-stepped. This is designed here specifically for steel. And that's one thing we want to address here is, Superion, they have a lot of capabilities, different geometries, different coatings that we can, provide for your application. And that's what you really need to reach out to us for, is if you're having an issue, you're having a problem, give us a call, reach out to us, okay? We have a solution. We'll develop, in this case here, we pretty much developed an entire package for it. So Daniel, you will please, we're ready to go. Let's crank these 15,000 RPMs and see what she does. And as you can see here, we're going to, it doesn't take very long. We're going around the OD of the part here in this case. Now that has finished the outside. I can show here real quick what that is. I'm going to flip me down to the bottom, Kyle. Okay, here we go. This here is doing the outside work. Okay. What we're going to do next to complete this is mill these cross slots. Okay, and that will be a completed Picatinny rail at that point. Okay. So Daniel, you will please. Then one thing to point out here is there's room for the chips to go, okay? As this thing, the tool is not enclosed, it's not encapsulated. The chips, you know, management here, just as long as we're making a chip, we're leaving a nice surface finish, a nice edge with minimal work to be deburring, anything afterwards. That's what we're really looking for here. This here is going to be cooking, again, 15,000 RPM max for the spindle, and we're going about 40 to 45 inches a minute, depending on the tool. This one here was at 45. And I'm hoping that picks up good because it is nice, smooth. There's no chattering whatsoever. It's performing very well. And there we go. And just like that, we have a completed Picatinny rail. And what we've seen thus far, there's been minimal, if any, deburring on this, okay? And that's one of the things that we want to do with a lot of the firearm-specific tooling is cut down on that gunsmithing. You know, any additional operations that we have to do with that, you know, that's just going to add time and consumption to your process. And that's just simply what you don't want. All right. You want something dependable, something to come in nice, clean cut, and finished up. So we have the one more to do. We have, now I mentioned everything there was external. Excited about this one. This one here is going to be doing an internal, okay? For this tool here, this is going to be doing your charging handle for the inside. 3 fluted, again, our PCD, and this is actually going to be doing 1 pass, okay? 1 pass, but it's finishing 2 sides, okay? So if you're familiar with this platform with the ARs, that charging handle has a channel that rides up and down. Well, that's what this here is going to be cutting right here with that little kicker coming out of the side. That's going to be making that channel, okay? So with that, Daniel, you will please. Now with this one, we are going to be, again, exercising 15,000 RPM on the spindle. We're going to come in and pay attention here because it's going to come down and it's going to go inside. That little bit of extra area here is just to help get that chip broke up and get it out of the way, the path of the tool. Okay, that concludes all the demos we have. Some things to touch on. If you're having any issues or having any problems, reach out to us. You know, if it's one hole, if it's an entire package, we have a solution. That's what we're here for. We'll put it together for you. And for those that reward you, if you're still with us, go to alliedmachine.com/firearms. Fill out the form for a brochure. And with that, we have limited supply, so act quick and you will be able to get a firearms sweatshirt. Okay? Greg, thank you. This has been a fun week.
Thank you. This has been a great job. I appreciate it.
No problem.
I'm sure everybody watching appreciates it. And for everybody who is watching, if you have any questions or want any more information about any of the things that you've seen here today, please reach out to us at ArizonaCNC.com. And also, if you happen to be in Arizona, particularly the Phoenix area, toward the end of this month, we are going to be having a demo day on Wednesday, October 27th. Now, during the demo day, you'll see all these parts running live, as well as some other components. We are going to have charging handles. We're going to have bolts. We're going to have bolt carriers, as well as several other machines running other parts. So we'd love to have you. You can go on our website again, ArizonaCNC.com, and register to be a guest at our demo day on October 27th. Also, I'd like to thank Daniel Simmons, who is the application engineer here at Arizona CNC, for doing a fine job in setting up this demo. I appreciate your efforts, Daniel. Thank you very much. And with that, I want to thank all of you for being here. Thanks everyone from Allied, and we'll see you next time.